In the second section for 8.1, we're going to start off with a little bit of review. Make sure we remember what we did in the previous section of notes. We are then going to do some subtraction, and we'll follow that up with a little bit of work on some word problems. So first of all, for some review, our first task is for you to create a third degree trinomial. So we're testing you on your vocabulary right here in these two questions. And again, I'd suggest you pause the video for the reviews and answer the question and then play the video again. So create a third degree. Remember, that gets a special name. If you forgot, you can page back in your notes. We call those third degrees cubic. So I could have said a cubic trinomial. This tells me the highest power I can have on my variable. This tells me how many terms. So my highest power is 3, and I have to have 3 terms. Beyond that, there's actually an infinite amount of right answers. So let's go make our highest power 3. You can throw any number in the world you'd like to in front of that, or nothing at all, and then we assume it's a 1. I can have 3 terms, but I have to make sure that they have a degree that's less than 3. So let's maybe say plus 2x, and then let's throw maybe a constant term of 8 on. So that's one of an infinite amount, but everybody better have 3 terms, and everybody better have a highest power of 3. Create a quadratic trinomial. So again, I'm going to have 3 terms, just like this one. Maybe I'll do a plus and a minus, doesn't matter. With a constant term of 10, so we usually have our constant trailing off the end here. We've got to lead the train with our highest power. Because it's quadratic, that means it's going to be a second degree. So let's just make it just a plain old x squared. Now, regardless of what anybody picks for their first term and their last term, there is something that's got to be common for that middle term. Because the highest degree is a 2, and I need to have 3 terms, everybody in here has to have x to the first. And let's maybe put a 4 in front of it. So there's one possible answer. Now it says to add the 2. So what I'm going to do is I'm going to take my first one that I created, and I'm going to take the second one that I created, and I'm going to add them up. And remember, with addition, it's really just a game of combining like terms. And the parentheses aren't serving any purpose except for grouping, so you can completely ignore them for addition. Alright, for addition, you can completely ignore those parentheses. So my highest power is a 3, so I'd have 5x cubed. Then if I want to keep it in standard form, I have a plus x squared. I have a positive 2x, of which I'm adding 4x. 2x's plus 4x's makes 6x's. Notice the power didn't change on there. And then for my constant term, I have 8 minus 10, which is minus 2. So there we go. Then it says, how would I name that one? Well, mine would be called a cubic because its highest degree is 3. And I've got 1. If that's all I saw, that I'd call it a monomial. 2 would be a binomial. 3 would be a trinomial, but I have 4 terms here. And once it gets past 3 terms, we call them all just polynomials. We lump them all together. All right. Next page. So now we're going to do some subtraction, and I know you've been taught in elementary school and junior high that subtraction is the same as adding the opposite. This is totally true, and it's a really good way to first learn about how not to make sign errors and stuff when you're first learning subtraction. However, if I were to ask you, what's 5 minus 2, I doubt there's anyone in here that says, oh, that's 5 plus a negative 2. I mean, it's a good way to discuss it at first. But when we get to problems with the polynomials, I really don't think you're going to want to be changing it to addition and then taking the opposite of everything. So it is true that it's the same as adding the opposite, but I think what's easier to consider is the fact that this is really a little negative 1 in here. You can think of it that way, and you're multiplying it into everything, and so what's going to happen is all those signs are going to change, which is what happens when I say take the opposite. That means change the sign. Another way to think about it is that we're subtracting all of this. So we have to subtract the 4x cubed, we have to subtract a negative x, and subtract a negative x squared, and then subtract a positive 2. And every time we have the double negatives there, we get a positive. So either way, you can think of that as subtracting everything, or you might even want to just put a little -1 in there and say, look, I'm going to be doing -1 times 4x cubed, -1 times -x, and what's going to happen is all those signs will change. I don't think you're going to want to change that to addition, because what happens is you lose your signs. I'm going to show you this in green and don't put it in your notes. For the kids who go and add the opposite, what generally happens is they do it right on their paper and they go, I'm going to add negative, plus, plus, minus. And you'll notice that kind of looks like sign vomit up there. I mean, you can't quite tell. And that's usually when people ask me for help. I look at them like, what do you got going here? And so I'm going to advise you not to add the opposite. This is what I'm going to advise you to do. Just distribute the negative in, or equivalently, you're really multiplying everything by -1 on the second one. What will you do with the first one? You're just going to keep that one as is. Just remove the parentheses. There's nothing out front here that you need to deal with, so the parentheses are just grouping them. But on this one, I have that negative to deal with, so here's what I'm going to do. I'm going to do -4x cubed, and then a negative and a negative makes a positive. A negative and a negative makes a positive. A negative and a positive make a negative. So every 2 negatives makes positive, just 1, and it'll be negative. Now we've just got to make sure we simplify this. So I have my highest power is a 4. My next one is the third power. Then I've got a -2x squared and a plus x squared, which is going to leave me down 1. You want to put plus a -1, that's fine, but again, that's kind of at this level. That's a little, I don't really like it. Then I've got an x plus another x, which is plus 2x, and -2. And here's my entire 4th degree polynomial. So we'll go do one more. I don't think we need to do 2 more of those. They're pretty self-explanatory. We'll go down and take a look at this one. So let's go take a look. We are going to take first one and just write it down because there's nothing in front of those parentheses, so nothing to distribute in. On the second group here, really I'm multiplying everything through by a -1, or you can think of subtracting everything, whatever you like better. If you want to put a little -1 in there, same thing. So I've got negative, I'm going to go in red here, I've got negative times a negative gives me a positive, negative and a negative gives me a positive, negative and a positive gives me a -x, and at the end here I've got 2 negatives again, which is going to give me a plus 10. So you'll notice it did have the end results of adding the opposite. That's now positive, that's now positive, that's now negative, that's now positive. So the end result is the same as if you were just to approach it as adding the opposite. So let's go combine our like terms. We've got 6x cubes. We've got -5 of those plus 1 of those gives me -4 of those. I've got a plus x and a minus x, which means I don't have any x's. And then I've got -3 going up 10 to a 7. So next page here, we are going to talk a little bit about word problems and tie this into what you learned last year. There won't be much like this in your homework, but I think it's good to tie in your previous courses with your new courses. So we are going to take a look at these. When you're doing a word problem, you got to look for words that mean you're going to add, because very rarely does it say add these. It'll say like maybe find the total, or it might say what's the sum, or what do you get all together. You know, those kinds of words. For subtracting, a lot of times we will see, well, what's the difference? Or how much more is one than another, kind of that type of thing. So we've got one example I actually like this problem because you got to know lots of different math with it. So here we go. You are doing a fundraiser. Let's suppose you're raising money for the swim team. And when all was said and done, you made 15x minus 100 selling those pizzas. But you had to spend 10x minus $50 on the pizzas. So it says, write a simplified expression for the difference. Well, that means I'm supposed to subtract them between the amount you raised. So I'm going to be taking the amount I raised and finding the difference between the amount that I spent. Now I purposely wrote this wrong, so just take a look at this. It's a very common mistake I'll see with subtraction, and see if you can figure out what I did wrong. In class I'd have you kind of raise your hand and we kind of figure out what went on, but I just want you to just kind of pause and think about, what did I do wrong? I wrote exactly what I said I was supposed to. The difference means to subtract the amount I raised, which is this, and the amount I spent, which is that. But I will get the wrong answer if I do it this way, and the reason is because I need to subtract the entire amount. So with subtraction, make sure you lock and load those in parentheses. You can be kind of sloppy with addition, but with subtraction, we've got to make sure we distribute that. I need to subtract it all, the minus 10 and the negative 50. And when you subtract a negative 50, you actually end up adding it. So those two negatives make a positive. So when I clean this up, combine my like terms, I've got 5x minus 50 represents the difference between them. Flashback question, what does that mean? That means I'm going to leave the world of exponential algebra and go back to your linear algebra class from last year. It says if you raised $2,000, so your 15x minus 100, I'm going to write this a little farther over here. Your 15x minus 100, my smartboard's squiggly, equals 2,000 because it says you raised $1,000. So remember from linear algebra, we've got to get that 100 out of there by adding it to both sides. It's 15 times x, so we do the opposite operation, which is division. And if I go to my calculator here, what's 2,100 divided by 15? My answer is x is 140. Next question. So how much money did you spend? Well, get back to the word problem. That's why I don't have to reread the problem again. A big tactic when you're doing word problems is pull out your key information. This text had two key pieces of information, the amount of money raised and the amount of money spent. And I just pulled that out and labeled it so I don't have to keep reading through it again. How much money did I spend? Well, I wrote right here that I spent 10x minus $50, and I wrote right here that x is 140. So I would have 1,400 minus 50, which would be $1,350. All right, so here's the deal. What if I said, what was your profit? I want you to not lose track when we're doing all this math about the big picture of the problem. I'm going to repeat that question. What if I said, what's the profit that you made? I want you to pause and think about that and write it. Put a little box over here. And you go figure that out and write it in the box. Pause the video if you're watching it. I want to know what's the profit. Go through everything we just did and think about, how do I figure out my profit? I take the amount of money I made. That's not my profit because I spent money doing this fundraiser. Remember? I don't get to keep that $2,000. I got a bill. For example, if I'm selling anything basically, like even used cars or candy bars or anything, it doesn't matter. That product costs money, and I had to buy it first. So I spent this much, and I made that much. So think about what you're going to do with those two numbers, and you should think, well, I got to take the amount I made, I got to pay off my bill for what I spent, and I get to keep the difference. So I had a $650 profit on that fundraiser. All right, so that's the end of the video, and we'll start the next one with section 8.2.